Okay, so we've seen a lot of these before. And as we recall, anything raised to the 0 power is equal to 1. Okay? Now, I will see people do this and they'll multiply 6 times 2 and get 12 and then raise the 0 power and think it's 1. But in reality, you do that first, and that is 1, but it still times a 6. So the answer there is 6. Generally speaking, though, anything to the 0 power is equal to 1. We also looked at something like that. When you raise it to a negative power, it's like taking something like, oh, I don't know, 4 to the 7th over 4 to the 9th. We subtract those exponents and we end up with 1 over 4 squared. Okay? We could also say if we're subtracting the exponents, it would be 4 to the negative 2nd power. Okay? So that is how we kind of go from a negative exponent becomes a fraction. A negative exponent means it's basically misplaced in the fraction. Negative exponent needs to be moved to another part of the fraction, so this is really 1 over 4 squared, which simplifies to be 1 over 16. Okay? And that's essentially, let's translate that down to here. This means this is 1 over x to the a power. If it's a negative exponent here, when you move it to another part of the fraction, it becomes positive. And oh, by the way, keep in mind there's a coefficient in front of that x that we don't usually pay attention to, but when you move this down, that coefficient is what stays up top. Okay, and the one that is invisible down here becomes invisible again when it's down here, even though that 1 is technically out in front. Now we can look at this a couple different ways. We can say it's 2 squared, which is 8, and 8 squared is equal to 64. That's true. We can also look at it as when you raise a power to another power, you're going to multiply those together. It would be 2 to the 6th power, which, by the way, is 64. Okay, so when you look at a number being multiplied or raised to another power, this is x to the a times b. Okay, these are the general rules down here. This is them put it into practice, and then down here we'll put them into more practice when we kind of mix them up. Now be careful here. It's very easy to look at this and say this is 2 to the negative 6th power because we're multiplying the 2's, so we want to multiply those. But in reality, this is 2 to the, you add those together, a negative 1. So that simplifies actually to be 1 over 2, or 1 over 2 to the first, if we kind of think of it that way, because the negative exponent means you're flip-flopping it upside down. Okay? So we translate that down here. When you multiply a common base, this is x to the a plus b. Okay, you're adding the 2 together. Even though one of them is a negative in this case, 2 minus 3 or negative 3 plus 2 gives us the negative 1 when we add the 2 together. And lastly here, this is, and by the way, it's probably the right time to make note of the fact that the 2 didn't change to a 4 when you multiply the 2 and the 2. Okay, you multiply them just like when you're multiplying exponent or variables together like this. This is still just x to the a minus b because one of them's a plus, one of them's a minus. That one looks the most like this here. But when we're dividing, it's a subtraction. There's 5 5's on the top and only 2 on the bottom. Means we're going to have 3 left on top. Okay, and we can kind of do that with sort of a shortcut by subtracting. 5 minus 2 is 3. And so if we look at this, this would be x to the a minus b. These are the general rules. This is kind of the rediscovery of those rules, and here we'll put them into practice.